Hello everyone, welcome back to Agentic RAG from scratch. In this series, we are building a production-grade Agentic RAG system from scratch. This is episode 7. In the last episode, we converted our existing LangChain workflow into LangGraph agent and got streaming working for both text and tool calls. If you haven't watched that yet, go check it out. The link will be in the description. Now there is one thing that's bothering me about our setup. We are still using InMemorySaver as our checkpointer. It's great for quick prototyping, but the moment your server restarts, everything is gone. All the conversation history, all the checkpoints wipe. That's obviously not acceptable for production systems. So today we are fixing that. We are swapping InMemorySaver out for a Postgres-backed checkpointer, which means our chat history and checkpoints will actually survive server restarts. Once again, welcome to Building SaaS channel. Let's get into it. So the core problem with InMemorySaver is simple. It lives entirely in memory. The moment you process dies, the data dies with it. For production, we need checkpoints stored somewhere durable. And Postgres is a great choice for this. LangGraphs make this pretty straightforward. It has built-in checkpoint provider you can just plug in. So first thing, let's install the package we need. LangChain checkpoint Postgres. Now let's set up our database connection. Inside the core folder, we'll create a dedicated database file. This is going to be responsible for managing our connection pool. We define a global variable pool typed as async connection pool or none, defaulting to none. Then we have two simple functions, getPool and closePool. GetPool checks if the pool already exists and returns it. If not, it creates one and returns that. ClosePool does what it says, shuts the pool down and stops accepting new connections. Now here is where it comes together. Over in the main file, we are adding a lifespan function. If you haven't used lifespan before, it's FastAPI's way of letting you run logic at startup and shutdown. Perfect for things like initializing a database connection. Inside the lifespan function, we first initialize the connection pool. Then we pass it into getCheckPointer, which spins up an instance of AsyncPostgresSaver and hands it back to us. After that, we call checkpointer setup, and this is an important step. This call creates all the necessary tables in your Postgres database if they don't exist and runs any pending migrations. So you don't have to manage that manually, which is nice. We then get our compiled graph by passing the checkpointer into getGraph. Inside that function, the checkpointer gets passed directly into compile step. Now let's see our route handler. We are passing the graph into the state map. So in the getGraph function, we read the state from the request and pass it as dependency to the route handler. Everything else stays the same. Let's fire up the server and see what's happening. The lifespan function kicks in, the graph compiles with Postgres checkpointer and setup runs. If I open our front end and send simple hi, it works perfectly. Now let's take a look at what LangGraph actually created in the database. We have got 4 tables: checkpoint blobs, checkpoint migration, checkpoint writes, and checkpoints. Whenever we interact with the agent on every step, a new record will be added based on the thread ID. If we explore the table rows in the checkpoints, you will see the checkpoints that are generated. Now let's look at all the tables and their responsibilities. Checkpoint stores the full graph state snapshot per step. Checkpoint blobs, individual state values stored as blobs. Checkpoint writes, intermediate writes for fault recovery. Checkpoint migration, tracks which DB migration have run. Now that we understand what these tables do, let's do a real test. I'll ask what car am I driving. Since this is the first time we are asking, it makes the tool call, fetches the answer, and stores everything in database. I am going to stop the server completely and start it back again. Refresh the front end and ask the same question. Instead of making the tool call again, it picks up exactly where we left off. The history and the context both are there. That's persistence working as expected. And that's it for this video. We have successfully replaced InMemorySaver with Postgres-backed checkpointer. Our application is one step closer to be production ready. Link to the code repo is in the description. If this helped you out, please hit the like button. If you have any questions, drop them in the comments. Do subscribe to Building SaaS channel and turn on the notifications so that you don't miss the next video. Thanks for watching. I'll see you in the next one.